we go to the chapter 5, electromagnetism. So I believe that all of you have an overview of what is magnetic bar, magnetic field, and so on. But now we recall and then we go to the further discussion on magnetism. So what is magnet? Magnet is a material or object that produces a magnetic field. Okay, so what are the type of magnet? So as what we can see from the slide, we have 4 types of magnet bar that you commonly seen. For the first one, we have U-shaped magnet, bar magnet, ring magnet, and also horseshoe magnet. So what is the magnetic field? Magnetic field is a region in space where a magnetic pole or current carrying wire experience a magnetic force. Alright, so magnetic field, we represent the symbol by capital B. It is a vector quantity, so it has magnitude and also direction of the magnetic field. So, and the unit is T, capital T, which represent Tesla. The magnets are polarized, means we have north and south pole. Opposite poles attract, while likes repel. So dia sama macam electric charge. Okay, so kita refer to this figure. So kita just nak recall balik. I believe that semua yang ni familiar. So magnetic field. So magnetic field kita represent by magnetic field lines. So the lines must coming out from north pole towards the south pole. So dia keluar daripada kutub north, kutub utara ni dia masuk ke kutub selatan. Okay. Actually, in this topic kita nak discuss further on the magnetism, but mula-mula kita pergi pada Oersted law. Apa maksud Oersted law? So it is discovered by physicist Hans Christian Oersted. So law ni daripada nama dia lah. It is a physical law discovered the relation between electricity and magnetism, which the Oersted law ni states that when a steady current pass through a wire, it creates a magnetic field around it. So in the experimental work, dia ambil copper wire, let's say lah copper wire, any conductor wire, and then dia attach to the battery. Okay, so they attach to the battery before he switch on dia turn on the switch tu. Dia place the compass near to the circuit, so tak ada deflection of needle in the compass. But when he turns on the switch, so meaning that the current flows in the circuit, so akan ada deflection of compass needle to certain direction. And then bila dia switch off balik, so the needle come back to its original position. Okay, then let's say dia replace the battery with different polarity. Dia terbalikkan battery ni, meaning that the direction of current dia akan oppose direction tadi tu. So needle ni dia akan deflect to another direction. So daripada sinilah eksperimen ni dia discovered the current, the conductor wire that carries current, ataupun dalam topik ni kita panggil current carrying wire, current carrying conductor. Okay, dia sebenarnya dia produce magnetic field around it. So dia akan produce magnetic field. Okay, okay. So now we go to the first case of magnetic field. For the first one, current carrying conductor. Current carrying conductor. So yang ni simple figure. Kita ada conductor wire, kita supply voltage. So apa akan jadi? So current akan flows in the circuit. So yang ni direction of current lah. Alright. So kita tahu by using right hand grip rule. So thumb ni dia refer kepada direction of current. And another fingers, ada 4 jari ni dia refer to the direction of magnetic field. So kita grip, right hand grip rule. Buat genggam macam tu. Lepas tu katakanlah you pegang pen sekarang ni, iaitu assume as our conductor wire. Alright, so kita pegang kita punya pen sama macam figure conductor wire ni. So kita akan dapat, so 4 jari kita ni dia akan pergi ke kanan. So maknanya 4 jari ni represent the direction of magnetic field. So dia mesti ada. So untuk long straight wire, kita boleh determine the magnitude of the magnetic field by using the formula µoNI over 2 pi r. Okay, nanti kita tengok yang ni constant dia. So r ni adalah distance from kita nak kat mana point kita nak cari tu. Alright, towards the conductor wire. Okay, so untuk long straight wire, the magnetic field dia bergantung kepada current, meaning that greater current will produce greater magnetic field. Alright, but greater distance, so dia macam electric charge jugalah, makin jauh charge daripada kita nak measure kan, so makin jauh daripada charge, so electric field dia weaker. So sama je konsep dia macam magnetic field, makin jauh point yang kita nak measure magnetic field, so makin rendahlah nilai magnetic field. And the last one, okay, µoNI, what we call as permeability of free space constant. So yang ni constant, tak perlu hafal, value tu kita provide. Okay, kita tengok example. A straight wire carrying a current of 250 ampere is placed horizontally. So dia placed horizontally 20 meter above the ground. So mana kat sini ni ada ground. Alright, so jarak dia adalah 20 meter. Now calculate the magnetic field strength at the ground level under the wire. So ditanya B dekat sini ni berapa? So kita imagine, let's say lah dia hold the current, the rod that carries a current. Katakanlah dia punya position like this, the current dia pergi ke kanan. So you refer to this figure, kita akan dapat direction of magnetic field lines ni like that. So bila dia nak pergi dekat ground, so R dia 20 meter lah. Alright, so µ0 4 pi darab 10 kuasa negatif 7. Darab dia punya current 250. Okay, over 2 pi, R dia 20 meter. Dan bila you calculate, state the unit, Tesla. Okay, another case for magnetic field, biasanya kita pernah tengok pada circular coil. Circular coil. Coil yang dia bulat. Alright, so the magnetic field, the formula is µ0 and I over 2R. Okay, so magnetic field, dia directly proportional to the number of turns and also current. Meaning that greater current, greater number of turns will produce greater magnetic field. But greater distance, meaning that the radius of the loop. So makin besar loop tu, magnetic field dia makin berkurang lah. Sebab dia inversely proportional. Alright, so I want you to imagine, let's say you ada gelung rotan. Tengok figure yang ini, nombor 1 ni dulu. Figure A, position 1, 2 and 3. So, direction, kita punya thumb ni. Okay, you punya thumb adalah direction of current. Another 4 finger ni dia sebenarnya right hand grip rule. Okay, tapi dia tak grip lah, dia buat straight je macam ni. So, B ni dia pergi keluar. Alright, okay, bila you pegang dekat position B ni, position B, current dia flows. Okay, B dia ke atas. So, B dia ke atas. Alright. So, sama juga at the third position, you have, so you imagine, you use your own hand to do this, to find the direction of magnetic field. So, magnetic field ni dia akan pergi ke atas. So, kita boleh conclude sebenarnya untuk circular coil ni, untuk position dia like this, the current flowing from this region, from this direction, then dia flows, dia keluar balik kat sini. So at the end kita dapatlah draw yang garis pink ni, magnetic field line dia, like this. So at the end kita boleh state, so the direction of magnetic field lines in this particular direction, meaning that this region adalah north pole and this region is south pole. So kita pergi pada example for circular coil. A circular coil has 18 turns. So ada 18 turns. So this is capital N with a diameter of 30 cm. Find the current flowing in the coil. Kita suruh cari current berapa. If the magnetic field strength at the center of the coil is 5 times 10 to the power of negative 3 Tesla. So dia dah bagilah nilai B. So untuk circular coil, formula yang tadi ni adalah B at center. Sebenarnya dia dekat another position of, maknanya dekat tepi, dia punya B ni lain. Tapi yang ini untuk circular coil ni, dia punya formula ni adalah untuk B center. Okay, now disuruh cari current, so you change the subject. Okay, at the end you just substitute the value. So B dia dah bagi. Okay, radius. So yang ni kita kena carilah. Dia bagi diameter dalam cm pula tu. So we cari radius 15 cm. Tukar is I unit. So 15 darab 10 kuasa negatif 2 meter. Okay, so we continue to how to find magnetic field for solenoid. Okay, formula dia, please be careful. You have to play around with the number of turns per unit length. Okay, so magnetic field is equals to µ0 and I. So n adalah yang kecil ni, small n adalah number of turns per unit length. Alright, so dia ganti daripada ke atas tu µ0 and I over L. Okay, so ada untuk solenoid, this is number 1. Okay, this is number 2. Ataupun kadang-kadang length of solenoid ni dia bagi in terms of circumference. So L equals to 2 pi R. So yang ni equation yang nombor 3. Okay, so now dekat bawah tu kita ada banyak contoh how to determine the direction of, how to determine the pole of a magnet. Kita nak kenal bila kita ada solenoid, kita nak determine the direction, the pole of north and south. Alright, so cara dia, you tengok figure yang ada yang number 1 ni. Okay, mula-mula kita kena identify of course the flow of current. The flow of current ni direction dia ke mana? So, kalau tengok dia daripada yang this one, dia akan pergi ke bawah macam ni. Dia lalu kat depan figure ni. Dia lalu kat depan macam ni. So kita guna our right hand grip rule. Okay, right hand grip rule thumb untuk menunjukkan north pole. Okay. Other finger yang lain tu direction of current. Alright, so direction of current, awak buat betul-betul ikut pada gambar rajah tangan ni. So tangan ni ke bawah, so that's why kita dapat direction of kita punya pole unit, kita punya pole sekarang ni, thumb kita menunjukkan pole. Alright, so kalau kita nak draw kita punya magnetic field lines, so kita akan dapat macam ni lah. Okay, so magnetic field lines ni, so this is the north, this is the south. Alright, ataupun tengok finger yang sebelah dia ni. Finger sebelah dia ni, kita tengok direction of current dulu. So current masuk dekat wire belah ni. So dia masuk dekat atas, dia lalu kat belakang. So kita dapat direction of current dia ke atas. So ingat, guna right hand grip rule. So 4 jari ni adalah direction current. Direction current, so thumb ni direction north. So you guna right hand grip rule. So yang ni direction current ni. Yang ni direction north. So kita dapat north kita sekarang ni kat kiri, sebelah kiri. Alright. So yang ni north, yang ni south. So untuk another 2 figure ni you can play by your own. Okay, kita tengok contoh how to find, kita nak guna solenoid, formula solenoid untuk cari parameter yang dia nak. A solenoid of 50 turns, so yang ni N, is carrying a current of 10 milliampere. The magnetic field strength at the center, so yang ni B. So calculate the length of the solenoid. So you must remember B, formula B, 1, 2, 3 tadi tu adalah magnetic field of a solenoid at the center. Alright, okay, So kita guna formula, you make it L as a subject dan kita dapat µ0 sebab dia bagi number of turns. So kita guna formula ni, µ0 Ni over B. Alright, so µ0 4 pi darab 10 kuasa negatif 7. And dia 50, current 10 darab 10 kuasa negatif 3. And you substitute the value of B. At the end you will get the length of the solenoid is 0.6 meter.